Good morning, my dear students. Today we are going to start with our last topic of this unit. Actually, this topic is generally not asked in the examinations, but yet we can have at least one question from this topic also, either in the practical portion or in the theoretical portion. This topic actually is not included in your course, but since we are dealing with this unit, we need to definitely get a look on this chapter. So what we are going to discuss today, we are going to discuss today about the latent heat. Now, do you know about what is the meaning of latent heat? So today we are going to discuss about that only, that what is the meaning of latent heat. So today's topic is latent heat. Now see students, we know that solid means, as far as we know that solid, when we heat this, suppose ice, it can be converted into what? It can be converted into liquid. And when we heat this further, means liquid, it can be converted into gas. This is a very basic thing that we all know. But students, do you know this, that this heat which is required to convert this solid into liquid, and this same heat which is required to convert this liquid into gas, this heat which is helpful to change the state of matter, what I am saying, to change the states of matter, the heat supplied, or the heat required. Now what is it? It is only, what we are talking about is the latent heat. In other terms, we can say this, that if we have to convert something solid into liquid, and if we have to convert the same thing into gas, the amount of heat that we'll be requiring is the latent heat, provided one thing very common, that the temperature must be constant. Now what does this mean, that what is the meaning of this temperature that should be constant? It means that when solid is converted into liquid, that time, if this is at x degree Celsius, this should also be at x degree Celsius. Now can we take any type of hint here where we see that the same thing happens? So yes, we can have that. Let us look at over here one very popular example. Now before we jump to directly the examples, let us understand the more deep meaning of what is the meaning of this latent heat. See students, latent means hidden. It is a type of heat. It is a type of heat which does not increase the temperature. Means even if you are providing this heat, the temperature will not be increased, only the state will change. Suppose you have ice. Now you know what is the freezing point of water. The freezing point of water is 0 degree Celsius when it is ice. Now suppose you start to heat it and you form water which is also at 0 degree Celsius only. But now since you have converted this solid state into liquid state, means some amount of heat has been required, but this heat has not increased the temperature, so means there is no visible change by this heat. We can say in other words that this heat is hidden. It has just changed the state but not the temperature. Any change in temperature is not taking place over here, only the change of state is taking place. Similarly, if you have water at 100 degrees Celsius. Now you have to make it by chance steam. Now you know that steam can also be at 100 degrees Celsius, but you know, since this is a liquid, this is a gas, means you have changed the state, means you have provided the heat but the temperature is not increased, means again you have provided a hidden heat which has changed this state but not the temperature. On the basis of that, we have two types of heat. First of all, I will tell you about the latent heat of fusion. See students, we have already discussed this latent heat of fusion right now, but I am just going to give you a little bit more of detail. Now see, the heat which is going into ice but not increasing its temperature is the energy required to change the state of ice from solid to liquid or water. Means what I am saying is, here I am having this ice. Suppose here is my ice. Now this ice is somewhere solid, Now I will provide it some heat. Some heat has to be provided so that it will change into what? It will change into water. But ice is at 0 degrees Celsius and water can also be at 0 degrees Celsius, means that we have changed this solid form into liquid form. So I was saying that only, it is that heat which is going into the ice but not increasing its temperature, and because of that the ice will convert into water, but temperature increase is not there. So this is known as the latent heat of fusion. Now if we define it, now what is it? It is, if someone asks the definition of what is the latent heat of fusion, you will write this, that it is the quantity of heat Now you will read, or you might have read in your physics chapters, that the unit of heat is joules. So it is the quantity of heat in joules which is required to convert 1 kg of solid, but mention that at its melting point, because this is the melting point of the solid, to liquid without any change in the temperature. Means you are not going to do any change in the temperature, you are just going to do what? You are just going to change the state of matter, that is your latent heat. Now this is a very simple definition, and we have also understand that what is the meaning of latent heat of fusion. Now let us talk about the latent heat of vaporization. What is the meaning of latent heat of vaporization? So I'll write here the next one. Okay, but before that I'll also take you to the back slide and I'll be giving you the value. Means what is the value of latent heat of fusion. So if we talk about ice, so I will write here latent heat of fusion, LHOF, for ice. Means how much quantity of heat is required for this ice. So it is 3.34 into 10 to the power 5 joule per kg of ice. Means for 1 kilogram of ice, if you have to convert it into 1 kg of water without any change in temperature, that you have to provide this much amount of heat, in joules. Let us talk about the latent heat of vaporization now. The same concept, nothing is changed, only the states are now changed. Means you are converting some other state to some other state. So what can I write over here in latent heat of vaporization? It is the quantity of heat in joules it is the quantity of heat in joules which is required to convert 1 kilogram of liquid. Now you have to mention this again, at its boiling point. You are taking that liquid at its boiling point into vapor or gas without increase in temperature. Means you have to not increase any temperature over here, you have to just convert this from one state to another. Now what is it that latent heat over here in this? For converting the water to steam, how much latent heat do we require? So latent heat of vaporization, I will write here latent heat of vaporization. For water is 22.5 into 10 to the power 5 joules per kg of water. Means you will take 1 kg of water and you will be giving 22.5 into 10 to the power 5 joules to that, so that you can convert it into steam without any change in temperature. Now students, you have noted that sometimes when we get a burn from water, and on the other side when we get a burn from the from the steam, then which one of them will be more severe if suppose in the case both of them are at 100 degrees Celsius? You have 100 degrees Celsius water, and on the other place you have 100 degrees Celsius steam. Now what do you think, in which of this following case you will get a more severe burn, in steam or water? So here the answer will be steam. Now why steam? Because you know that everything which will come to the which will come in touch to our skin will require what? It will be cooling down, because our skin has a lower temperature. So because skin has lower temperature, what will happen? The heat is released, we know this thing, to convert, or we can say to solidify. Because see, now the temperature is less. Now what do we expect for liquid? Liquid will decrease its temperature, similarly gas will decrease its temperature. But students, you see that if we have 100 degrees Celsius water, it will be giving less burns when we compare it with the 100 degree Celsius steam. Why? Because 100 degrees Celsius steam will first convert into 100 degrees Celsius water, and at that time, because it is converting, it is losing its heat. That time latent heat of vaporization, which was hidden, will also be released out. Means this will also cause you burn. So we will say that the latent heat of vaporization released during cooling of steam, we know this thing. So during the cooling of steam, this latent heat of vaporization which will be released will cause additional burns, and as a result, what will be having here, because of this latent heat of vaporization, we will be having the more severe burns as compared to the normal water. Similarly, in another case, you have this latent heat of fusion for ice. So there is one more thing over there, that when you taste or when you eat ice at 0 degrees Celsius, or sometimes you eat ice cream, it will feel more cooler. Ice cream feels more cooler. Why? Because when it is in solidified form, it will first convert into liquid. At that time, the latent heat of fusion will be required to convert it. That time what will happen, that additional heat will be absorbed from your teeth. Normally if you are drinking something very cool, water, but if you are taking ice cream, so that time this ice cream will melt also. For melting also you will require more heat to melt that ice cream. So because of that, this latent heat of fusion will be absorbed from your teeth, and you will feel more sensation as compared to a cold liquid water. So that's all for the day, students. Thank you and have a nice day.